So, hello guys. I hope you all are doing absolutely fine. And in this video, we are going to continue our discussion about the fundamentals of the Pipecat and voice AI agents. In the previous video, we have completely understand about how a basic voice AI agent work, what is the philosophy of Pipecat, what is frames, what is frame processing, what is its pipeline, how the turn taking is done, how the latency will be less, how Pipecat ensures that, how Pipecat ensures the context management and all. So why we are doing this video? We are doing this video because what I will do now is I will go through the file which was this bot.py file, which is the main file which we have seen inside the quick start example, and I have just given you the overview of that. But now you are ready to understand this file completely, and the things like the black boxes which are there, like there are some things like this RTVI, this was there, and then there is this thing called pipeline task and all. So I will, like, you will in this video you will understand the coding philosophy of Pipecat. Like, you have understood the theoretical concept, but how to implement the Pipecat code and all, you will understand that in this video. So what we are going to do, firstly we are going to run a overview, like overview from through this file, and note down the all the like unknown things which we have right now, and then we will understand their functions. And like after this video you will completely understand each and every part which is written inside this file, bot.py file. And trust me, if you understand this file, you will know that how to implement your Pipecat code. Okay, so you can uh, implement any type of code. You just have to go to your documentation, just use the ask AI feature, give your requirement, it will give you the recommendations, and then using the understanding of this video of the coding concepts of the Pipecat, you can code the use case easily. So this is the last fundamental video, and if you like give attention to this last video, and thank you for giving the giving your attention by the all the previous videos, and just to keep it with me in this video also. And after this video, all the implementation and all will feel a piece of cake for you guys. So let's get started and let us do it. So let me like simplify this file a bit. So here some docstring is written, like to run this thing and all. So here what we are doing, we are importing the necessary things like OS and .env, so that we can get the .env things and all. And then we are just logging some things that this model is ready. So see what we are doing, we are loading this turn analyzer which we have discussed, the one of the superstar for managing the turn taking challenge. And then there is this VAD, voice analysis detector, and we are using this scenario VAD. So there is this scenario VAD model which we are using to detect the voice activity inside our voice agent. And then we are using this VAD parameter, then LM run frame. I hope you know this is a type of frame, right? There are multiple types of frame which we have seen inside the flowchart. If you go inside the flowchart, we have seen, right, there was multiple types of frame. So similarly we have imported a particular type of frame. Then we are importing this pipeline, then we are importing this pipeline runner, then pipeline parameters, pipeline task, then LLM context. There are a lot of things which you don't know right now. Like, you don't know this, you know, like what is this pipeline, but you don't know why this runner is mentioned here, why this pipeline parameters is imported, what is this pipeline task. Then LLM context, I hope you know now that LLM context will be used to manage the LLM context, so it is giving some idea. Then LLM context aggregator pair, you don't know right now. Then RTVI, you don't know right now, I will tell you that also. Then why this runner argument is said here. Then what is this create transport is doing. And then this Cartesia, I guess you know what it is, because this is a TTS service, text to speech service, so we are using Cartesia for that. So I've told you that a frame processor will use this Cartesia TTS service to convert the text to speech, and similarly deepgram for the vice versa thing, which is speech to text service. Okay, and then there is this grok LLM service. I already explained you this inside the Pipecat quick start example. This is the LLM service we are using, but we don't use the OpenAI one because that is paid. We are using the grok one. And then there is this transport. So what was transport? If you guys remember, transport for is used to manage the input and output of the audio data from the client. It just sits on the top of the pipeline and the bottom of the pipeline. If you go inside the flowchart and see, transport is on the top of the pipeline and the bottom of the pipeline. Okay, so you can see So we are just importing that here. So we are using the base transport and transport parameter, and this daily transport we don't need, so I will just delete it. So basically there are multiple types of transport. The one is the base transport, and we can use a daily transport also, but in this course we are going with this base transport. Then we are loading all the env variables. Then there is this two main functions. See, the one is this bot, and then there is run bot. Okay, and there is this main. So let us go ahead and let us see how everything works together. So here there is this something called as a bot function is given here, and it is taking an argument which is named as runner argument, and there is this is a type of runner arguments type. Okay, so so why this has written here is, see, when when we write na uv run bot.py, and if I give an runner argument here, like I will write here web rtc like this. So this web rtc will be gone as a runner argument inside this bot.py, and then this particular web rtc transport will be configured. This particular web rtc transport will configure. So here can be some another configuration of the transport also. Like if I copy it and if I say here by yeah, and if I say here this one also, and if I say daily here, daily. So obviously I have to change some other parameters here also, but for your understanding, what I will do, I will just write here daily, daily. So this particular transport value will just pass on to this runner argument types, and this one daily one transport will be configured and it will be used as a transport. And what is this transport? If you go inside the pipeline, to handle the input and output, and it also manage the sessions, initialization of session and all, which we will see further in this video only. Okay, so I hope you got this, why this runner argument is mentioned here. And you must be like thinking, let me delete it first. You must be thinking that how this bot will, who is calling this bot thing, bot function, and who is passing this run argument from this particular uh, slash slash daily. So it is all handled by this main function. So all this internal logic is written inside this pipecat runner.run, from where we are importing this main. So this main function automatically calls this bot function which is present inside this bot.py, and it sees for the argument which was given, and it automatically pass on that argument to this bot function according to the parameter value which has given here. And accordingly the transport params variable is set with the particular selected transport. Now what will happen next? This transport will, we will use a create transport utility function. So if you go on inside here, so see, it's like a utility function which is provided by pipecat itself, and it is like just imagine that what it is doing, it is creating the transport layer for us, and it is handling all the connections with the client, so that we can do input and output of operations with in the form of audio from the client to this pipecat pipeline. So this is the first step of that. So that's why we are creating the transport instance, and we are storing that inside this transport variable. And then what we are doing, we are calling this function which is run bot function, and we are passing transport with our runner arguments, which was not daily, which was web rtc in our case, so these two things will be go to the run bot function. Now let us see what this run bot function is doing. So see, inside this run bot function, it is expecting a transport. So we are already giving the transport, which has what the transport will have. It will have the configuration information which is required to send and receive audio data from our client. Okay, so that we can so that our voice agent can communicate with the external world. So that's why we need this transport here. And then this is runner arguments is also important, so we are getting that also here. Now what we are saying, we are starting the bot here, so we are giving a log. Then we are initializing a deepgram std service here, and this std service which deepgram requires a connection and authentication, so that's why we are giving the deepgram api key here. Then this is the tts, the cartesia tts service, and also for that, like this, why I have given this voice id, because TTS is a TTS service, text to speech service. So we want some characteristic of voice. Like my have some characteristic, you have some characteristic of voice. So similarly there are different types, characteristic of type, voice types which are there, and one particular voice id is there. So if you want some another type of voice characteristic for your agent, you can just change this voice id. You can easily find it inside the cartesian, you can change that. Then here this TTS is initialized, then we are getting our LLM. So our base services like our STT is there, our TTS is there, and our LLM is there. Now we have configuring the message, system message, which our LLM will have as a system prompt. So it will like judge the behavior of our voice AI agent. Then what we are doing here, we are managing a context. We are managing a context. So we are saying this is a LLM context. This is a LLM context. So this is for LLM. So that's why this LLM context is given by the Pipecat itself also. So why I am using this LLM context here and not passing message as it is to the context, because this LLM context is given by Pipecat and it's optimized to used in a frame driven environment. So that's why we are converting this message and giving it inside LLM context uh, object, we can say, and then we are storing that instance with that message value inside this context. And then what is this context aggregator do? I hope you guys know that it's maintain the context of all the conversation history. So currently what is the conversation history? We have only this system message right now. So imagine like what we are doing here in this line, that we have this particular array like as a role and the content, we have that here. So if you guys remember, we have a array here which was maintaining the context. I think I've deleted that, but imagine there was a array. Okay, this was the array. Okay, inside this array we have this role as a system and this thing. Okay, so this is the one r, this is our one value here, this complete our one value. And similarly there will be another messages, like now if I say something like this system, now bot will reply. So there will be bot, like role will be agent, role will be agent, and then will be some content specifically related to that, what is bot has spoken. So there will be some content like okay, and something. So I hope you understand what this context aggregator is doing. It's just aggregating the context history, and it is aggregating that inside this context aggregator variable. And we are specifically using LLM context aggregator pair. If there was, if it was the user, we would use the user context aggregator pair. And if we have imported that also. Like see, we have this LLM context aggregator, and the bottom of the pipeline we somewhere has this other things also, like the user context management also. So I have to understand this also. This code is clear, I guess. And then what it is here, this is RTVI processor, and we are configuring it with some variable. So now uh, like let's understand this RTVI, and let's undiscover like let's uncover the what is the concept of RTVI and why it is important for our Pipecat. So see, RTVI RTVI is a very important part, plays a very important part play inside our Pipecat. So why it is used? See, RTVI has two things inside it. RTVI is a processor, and there is another thing inside RTVI, which is a observer. So what is the role of this processor and what is the role of this observer, and where does it sits basically? So if you see inside this pipeline, so you can see we have used the RTVI processor here, not the RTVI observer here. Okay, if you are paying attention, this is a processor, not a observer. So what is the role of processor? Role of processor is basically, imagine a client say, imagine a client sends some message for the pipeline, and we want then some specific event should be occurred according to the result. Like for example, let's say here was a client. Okay, and let's say it sends an event to our pipeline, and this event name was hi to RTVI. Okay, so this was hi to RTVI, for example. So this RTVI event, so which player inside this Pipecat pipeline will be responsible for processing and looking for these events, and doing some specific actions based on these events. So like the transport is not responsible for that, right? STT was not responsible for that. Context aggregator has different things, another services, another things. But this RTVI is dedicatedly, RTVI processor is dedicated here, and it's actively looking for this type of events which is coming from the client. Okay, and when this particular events are come inside this RTVI processor, RTVI has already written the logic inside that. Okay, so it's like a if logic, like if here I have written if RTVI, if we got this event which is said hi to RTVI, you have to you have to here execute some action. So this RTVI processor will do that thing. RTVI processor will look actively for all the events which are sent from the client, and if there is some actions which are written or tied to it, then it will do that action. And in this particular action, we can again send some particular events to the client. So that is also a responsibility for the RTVI. So RTVI processor is kind of a bidirectional uh, capability. Like it can listen for all the events which the client is sending inside the pipeline, and it can also send the events to the client again. So like a real example, I can say that here in our code base, if I run our uv run bot.py. So if I open this particular client, okay, if I open this particular client, so you can easily see that we are getting initialized here, and if I connect that, then we are getting this client ready here. So how do the client knows that the bot is ready? How do the client knows? Because RTVI is send that okay, the bot is now ready, so it send the event to the client, and the client knows that okay, the pipeline is ready right now. So that is the responsibility of RTVI processor. So I have to understand that RTVI processor, what it do, it has a kind of a bidirectional role. It listens for all the events which client sends to execute some actions, and it can also send some events to the client so that clients can understood that what is happening. So it is done. Now what is this then why this processor is done, we know now that why this processor is being utilized here. Now why this observer is been made here. So see, imagine observer as a person here, and it is observing this complete pipeline. So imagine here is a person whose role is to observe this complete pipeline. So what it will do, it will log every action, and it will take account of every action which is happening inside the pipeline. So for example, user speech were there, then this transport has given this user input. So this audio frame will be observed by this particular RTVI observer, and it will make inside a, like we can say, kind of a log. So this will be registered inside the RTVI observer log. So I can say here, this is RTVI observation observation. So all these events which are happening, the frame conversion and all, like again there's RTVI processing is done, then there is this transcription frame. So this transcription frame again will be so this transcription fail will also be like inputted inside this. Then again this LLM context frame. So all this observation, like it's just its role is to observe the particular things and get the events which are happening inside the pipecat itself. So it is it sits outside of the pipecat pipeline, and the RTVI processor sits inside of the pipecat pipeline. Okay, so there is a major difference between that. So that's why it's called a processor and it's called a observer. So observer sits outside a pipecat pipeline, and it observes all the events which are happening inside the pipeline. Okay, and there is no connection between the RTVI observer and the client. Okay, RTVI observer is used to observe the internal working of the pipeline and internal events happening inside the pipeline, but RTVI processor is responsible for handling events which are coming inside the pipeline from the client, and getting executing some actions, and again sending back some events to the client based on that particular actions. Okay, so RTVI observer is for some observation related to the internal pipeline matter, and RTVI processor is for handling and executing some action based on the events you are getting from the client, and it can also send to the client also. Okay, so I hope you understand the concept of RTVI. Okay, and like um the RTVI concept is now demystified. Now what next things we need, we are come up with this pipeline construction. We already know about this pipeline. So here, like in the next video, what I will do, I will explain you what is what is the difference between this pipeline and pipeline task, and why we have written this here, and then what is this pipeline runner. And after the understanding of all this, we are going to understand how this complete, this pipeline task communicates with the uh, client. And here I will exactly tell you where the RTVI sits. Okay, so you will get a more clarity of that also. So I hope you learned something new inside this video also, and I hope you are excited for the next video. So keep learning, keep growing. Bye bye.